Okay student, this is the third part of integration. This part is important for us. Methods of integration. How to find the integration of function. So we have the several methods. Among them these three are important. So first one is integration by substitution. So integration by using partial fractions. Integration by parts. Integration by parts is just like UV formula, this one. Integration by parts. One by one I will explain. So this part is important for us. Okay students, first of all, integration by substitution. What is the meaning, how to use it, I will explain now. Okay, integration by substitution. Actually I want to explain through one example now. Integration by substitution. For example, integration of sin 3x you want, sin dx. Directly you can say answer for this is minus cos 3x by 3 plus c only. Okay, actually. But how I can use the concept of integration by substitution? So I will explain. Integration of sin 3x into dx. So meaning of the problem is you want to integrate this function with respect to x. Now integration by substitution means you want to change the variable. Actually you want to integrate with respect to x. No, you want to change the variable, means you want to integrate with respect to another variable t or k, like that. For do such operation, just take this as some t. Let 3x equal to t. Differentiating with respect to x, what will write in generally? 3 equal to dt by dx. Okay, but in integration concept, same thing can be written as 3 into dx equal to dt. Nana. Meaning is same. Notations are different, but their meaning is same. Nana. So 3 into dt by dx is written as 3 into dx by dt. Don't think that here cross multiplication is applied. It's not correct because it's not a fraction. But in integration concept you can write like this. Okay. So now I want to change total problem. Integral of sin into, instead of 3t I can write it t, 3x I can write it t. Instead of dx I can write it dt by 3. Okay, this is nothing but 1 by 3 into integral of sin t dt. So that is 1 by 3 into minus cos t plus c. So our answer should be in terms of x. That's why 1 by 3 into minus cos, instead of t, what I can write 3x I can write 3x plus c. In this way you can use integration by substitution. Suitable substitutions. By using suitable substitutions you want to find the integration of given functions. Now. So now I want to explain some problems. Here also given working rule, integration by substitution. In this section we consider the method of integration by substitution. The given integral dx can be transformed into another form by changing the independent variable x to t or some k by substituting x equal to gt. So consider I means need to find integral of this. That is integral of f of x dx. Put x equal g of t. So that dx by dt equal g dash of t. Same thing what I explained here clearly given. So one example problem, students. One by one I will explain. First example problem. Integral of sin mx dx. Okay, now I want to change the variable. Let mx equal to t. M into dx in integration notation I can write dt. So the problem I can say I will write, always I will write I. Now I can say I is becomes integral of sin t into, instead of dx what I can write nana, dt by m. So this I is nothing but 1 by m integral sin t into dt. So I is equal, so 1 by m into minus cos t, okay, plus some constant c. So minus 1 by m into cos t. T at last, instead of t what should write, mx you can write mx plus c. This is the integration of that function. Okay, I hope you people understood the method. Interesting one, important method. Second problem, students. Integral of 2x into sin x square plus 1 given. dx. Let it be I. Okay students. Now x square plus 1 is taken as t. 2x into dx can be written as dt. Okay. So x, okay. That only I want. Wait. So now I becomes, so sine t, integral sine t. So this 2x into dx, instead of 2x into dx, what I can write? dt I can write, directly dt I can write, dt. So what happened to I will write here, Nana. I is equal to now minus cos t plus some constant. So now I am finalized. I don't want t now, I want x. So instead of t, what I can write? X square plus 1 minus cos into x square plus 1 plus c. This is the answer for the problem. In this way, we need to use suitable substitutions. Okay. Okay, so another problem, third problem, important and interesting problem. IMP can write. Okay, students, listen. Integral, say I can say tan power 4 into root x into secant square root x by root x equal to into dx equal to dt. Sorry, equal to dash. Okay, students, what should take? What should substitute? So interesting thing is, let root x equal to t nano. So differentiating 1 by 2 root x into dx equal to, I can write dt. Or dx by root x equal to 2 dt. Now this problem is changing as tan power 4t into secant square t. So dx by root x means I can write 2 dt. So what I can say, I equal to 2 into integral of tan power 4t into secant square t into dt. So this becomes lengthy now. Instead of root x, you can, if you take tan root x as t, then problem becomes easy, I think. So already I started now. I want to complete in this way only. Listen, all of you. Yeah. So here again we need to substitute something because tan secant is involved now. I equal to, students, just again, yeah, tan t differentiation is secant square t only, no? That's why let tan t equal to another variable k. So secant square t into dt, I can say dk in integral language. So I now becomes 2 into integral of, yeah, tan k is taken as, tan t is taken as k, this is k power 4 to secant square dt. Secant square dt means dk I can write. So finally what I got, I equal to 2 into t power, sorry, k power 5 by 5 plus c. But you don't want k, students, you want in terms of x. Listen, first of all, so this I equal to 2 by 5 into k means what I can write? This tan I can write, tan power 5t plus c. But what is the actual answer? Should be in terms of x only, no? 2 by 5 into tan, instead of t, what I can root x I can write, root x power 5 plus c. This is the final answer for the problem. Okay. Okay, students, if you take a sine root x as t, what happened? You will observe now. Tan root x is taken as t. Okay, what happened? Secant square root x into root x differentiation 1 by 2 root x into dx equal to dt. Or what I can say, secant square root x, okay, by root x into dx equal to 2 dt. So instead of this, directly I can write 2 dt. So I equal to integral of tan root 2 t means this is t power 4 directly. Okay, t power 4 into what happened 2 dt. So what happened, I is equal to 2 into integral t power 4 into dt. Okay, so what is this, Nana? I equal to 2 into t power 5 by 5 plus c. Okay, now I am completing. Observe. So this is equal to I equal to 2 by 5 into t means what, Nana? Tan root x power 5 plus c. Observe, in both the ways we got the same answer, but second method is easy than the previous. Such a way that you want to substitute, Nana. So instead of root x is taken as t, you got the answer. So while observing the problem, we can say that tan root x should be taken as t. Then problem becomes easy for us. Okay. Student, this is important concept, Nana. Finding integration by substitution. Yeah, next problem, I can say this fourth problem. I is given as integral sine of tan inverse of x by 1 plus x square into dx. Just observing the problem only you can say what should substitute. Tan inverse x is taken as some t now. Let tan inverse of x is taken as t. So 1 by 1 plus x square into dx is nothing but dt in integral language. Understood? So what happened? What is the meaning of this? Instead of this, what I can write? dt I can write. Okay. So now I becomes, students listen, I becomes integral sine t, that's all, into dt only. What is that? Minus cos t plus c. I equal to minus cos into, instead of t, what should write? Tan inverse of x you can write. Okay, plus c. This is the answer for the problem. Or sometimes so you can write a cos also in terms of tan, then direct will get a total in terms of x only, x. Okay, that is not big problem. In this way you can solve this problem. Students, IMP results, very very important. 1 minute. IMP results. Some important integrals involving trigonometrical functions and their standard integrals using substitution technique. These will be used later without references. Okay. First one, I can say I equal to integral of tan x. We want to find its integration. Okay, actually we need to remember integral of tan x dx as log of mod secant x plus c. Should remember like that. How? Means I will explain. See, integral of, I can write sin x by cos x into dx. Okay, cos x is taken as t minus sin x dx becomes dt, or sin x dx becomes minus dt. Students, I is nothing but now integral of this is I now, this is I. Sin, this sin x into dx, what should I write? Dt minus dt I can write. By cos x is taken as t. Finally, what I got? I equal to minus 1 by t into dt. Okay, students. So I is equal to minus logarithm of mod t plus c I can say. Okay, or sometimes I can write I equal to minus logarithm of cos t, cos x plus c. You can remember like this also. Integral of tan x dx means minus log mod cos x plus c. Or another language I can say that I equal to logarithm of secant x plus c. So what logarithmic properties involved means logarithm of x power m equal to m into log x to some same base, either e or a, whatever it may be. Okay. So this is one of the important results. You should remember, no? Integral of tan x means log of mod secant x plus c. Like that, integral of cot x should be remembered as log of sin x plus c. Proof is easy only for us. That is taken as I equal to integral of cos x by sin x into dx. Here sin x is taken as t. Okay, cos x into dx equal to dt. So now I becomes integral 1 by t into dt. Students listen, instead of cos x dx equal to dt. Now I is equal to what happened to that, Nana? Logarithm of mod t plus c. So I equal to logarithm of mod t. T means what? I took sin x plus c. Therefore, integral of cot x dx should be remembered as logarithm of mod sin x plus c. Okay. Yeah, here also integral of secant x dx. Listen, once again listen students, important thing is this chapter is fully depend upon memory. This chapter is fully depend upon memory because we will derive several results. Using those results only you can solve the problems. Several results. Okay, at least 30 or 40 results should remember. Without those you can't solve the problems. Okay. So third one, integral of secant x dx. This is one of the interesting thing. So 1 by cos sin square. So I want to make a plan. 1 by cos here, sin square x plus cos square x. So what up tan x into secant x plus cos x. Okay, this is what happened directly. Integral means the integral of this is secant x only. So tan x not there, again logarithm should use. Okay, you need to use another alternate method. What is actually I thought that sin x can be written as 1 by cos x, 1 can be written as sin square x plus cos square x. After splitting, so I'm not getting direct result. We'll get something, the result is correct only, but I'm not getting this directly. What I should do? Okay, now I want to use another alternate method for this. Students listen, important this one. Integral of secant x into secant x plus tan x multiply divided. Okay. Now numerator is secant square x plus secant x into tan x by secant x plus tan x into dx. So this is I. So this is I. Students listen. Let secant x plus tan x as taken as t. Secant x derivative secant x into tan x plus tan x derivative secant square x. Totally dx I can say dt in integral language. See this is only numerator. So instead of this total, what I can write now? Dt I can write. I equal to integral of dt, but instead of this t I can write. What is this nana? Logarithm of mod t only plus c. That is logarithm of t means what I can write? Secant x plus tan x plus c. So student, this is important. You should remember this. Okay. Similar way you can find the integration of this function here also. Secant x that into cosecant x minus cot x by cosecant x minus cot x, and proceed, you will get the result. That is not a big problem. Here our problem is to remember. You should remember all these results. That is only very difficult task. Yeah, some example problems. Find the integrals of the following functions. So these all are belongs to that category, substitution category. Okay. Yeah, sin cube x into cos square x. What should take as t or k? I think anything you can take, cos x or sin x, anything it happens. I want to take cos x as a t. Okay, I want to take sin x as a t. No problem. You can take cos x or sin x, you will get the same result. Cos x is taken as t. Better is I think cos is better than sin. cos x into dx equal to dt. So instead of 1 cos x into dx, you can write dt. One more cos x will left. With that cos, what should I root over 1 minus t square? No? Roots will get. That's why I don't like sin x as a t. I want to take cos x as a t. Understood what happened here? Again I will explain. If you take sin x as a t, what happened? I am explaining now here. This is cos x into dx equal to dt now. Actual problem is what? Sin cube x into cos x into cos x into dx. Instead of this, we can write dt. So instead of sin cube, t cube we can write. Instead of cos x, what should write here? Cos x, what should write? Root over 1 minus t square only. So roots are getting, some problem becomes complicated. That's why what I should do, I want to take cos x as it instead of sin x as it. Let cos x is taken as t minus sin x into dx equal to dt, or sin x into dx equal to minus dt. No, our I becomes, students listen, actually again I will write the problem, sin square x into cos square x into sin x into dx. Okay, so instead of this sin x cos dx, what I can minus dt I can write. I will write here I. So sin square x means what is sin square x means 1 minus cos square x. Yeah, this cos square x as it is, this sin x into dx as it is. Now instead of this I can write minus dt. Students listen, I is equal integral of 1 minus t square into cos square x means again t square into minus dt. I will write minus here dt. So what is this then? I equal to or minus I equal to t square minus t power 4 integral with respect to time t. So minus I equal what happened? T cube by 3 minus t power 5 by 5 plus c. Now I want to finalize it. Yeah. So I equal to t power 5 by 5 minus t cube by 3 minus c you will get actually. Oh, that is not big problem. Plus c also you can write. That's constant only, no? Okay, now final I equal to t. What is I took cos x is taken as t, no? That's why cos power 5x by 5 minus cos cube x by 3 plus c. This is the integral of that function. Okay, students, first problem completed. Interesting one. So now I want to find the solution for second problem. I is taken as integral sin x by sin of x plus a into dx. Students, if that sin of x plus a is in numerator, for example, so I can split it by using sin of a plus b formula. After that I can find integral, but sin of x plus a is in denominator. Let x plus a is taken as t. Dx equal to dt because a is constant here. So now this I becomes, students, instead of sin into, instead of x what I can write t minus a by sin t into dt. Understood? Okay. So this is sin t into cos a minus cos t into sin a by sin t into dt. So what should I write now here? Integral of cos a minus integral of cot t into sin a into here dt. Here also I can write dt. So students listen, here interesting thing is, yeah, what I took x plus a as a t. Okay, that should remember. Yeah, integral of cos a into 1 dt minus, yeah, what should I write? Sin a into integral of cot t dt. So here interesting step, cos a into this is t minus sin a as it is. So instead of this, what should write? Should remember log of mod sin x. Should remember none of that one. Log of mod sin x and sin t I can say. Plus c. Now I want to finalize. Instead of t, what should you write? Nana x plus a you can write. Cos a into x plus a minus sin a into logarithm of mod of sin of x plus a plus c. Okay, student, this is the answer. But for example, in objective type question, if the option is given like this, x cos a minus sin a into logarithm of sin of x plus a plus c, you will confuse. This option is not there. You got this, but this option not there. What should do? Actually, these two are same. I will show you. Multiply cos a into x plus a cos a minus sin a into logarithm of mod sin of x plus a plus c. Actually, what happened here? So instead a cos a constant only, c constant only. Instead of that, again they wrote another constant. Means what happened? X cos a minus sin a into log of sin of x plus a plus just c. So instead of this plus this is a c1, this is c2. Like they can write c. That is interesting thing. That's why this is correct answer. This one also correct answer. But what I can say, this is simplified answer. Okay. Important property. It's very, very important. Integral of f dash of x by f of x dx. Directly I can say the logarithm of mod f of x plus c. Okay. So let f of x as t nana. So f dash of x into dx equal to dt only. So this is a I. Actually, what happened to I? Integral of dt by t only. That is equal to log mod t only. That is equal to log of f of x plus c. That's why this is important. You should remember this. This is important property. F dash of x by f of x dx, directly can say that logarithm of f of x plus c. So this is one of the interesting problem. Third one, IMP. So integral of 1 by 1 plus tan x. Okay. Yeah. Directly I can write this is cos x by sin x plus cos x. Just 1 by 1 plus sin x by cos x is taken as LCM. Yeah. Here onwards problem making difficult for us. So in numerator also I want sin x plus cos. Just I will write sin x plus cos x. Cos x added, should subtract cos x. Okay, plus one more sin x I write. What is the problem of this? If you write 1 by 2 by sin x plus cos x. Why? Because sin x plus cos x derivative what nana? Cos x minus sin x. Numerator also I want cos x minus. That's why I divided, I added, subtracted cos x and sin x. Okay, observe here what happened. So cos x added, these two get cancelled. Sorry, I think this is not correct. Cos x plus sin x, here plus, here minus, I think. Now better. Yeah, what happened? Cos sin get cancelled. 2 cos x off. Okay, now correct. So I will write neatly this is equal to 1 by 2 into sin x plus cos x plus cos x minus sin x by sin x plus cos x. Okay, students, listen. So this is same as 1 by 2 integral of this way this 1 plus cos x minus sin x by sin x plus cos x into dx. This is x by 2 plus 1 by 2 integral of cos x minus sin x by sin x plus cos x into dx. Okay. Yeah, students, listen. What I got, I want to write here. X by 2 plus integral of cos x minus sin x by sin x plus cos x dx. Observe, Nana. If, for example, sin x plus cos x is taken as t, cos x minus sin x into dx equal to dt only. No? That only numerator. Okay. Directly, this is in the form of f dash x by f of x into dx. Or directly I will write x by 2 plus integral of f dash x by f of x form. That one. What I can write x by 2 plus one more 2 will be, I forgot to write that. So 1 by 2 into logarithm of sin x plus cos x plus c. This is the final answer for the problem.